Okay, so this is 8B, problem number 8, solved by substitution, problem B. Again, we kind of give you a little helpful hint here. Obviously, we have an equation for a circle, and we have a quadratic equation, and so that's why you see your parabola and you see your circle. So I'm fully aware that you can see that it intersects at 3 points. And this is really helpful, but you need to have the substitution work to support that. So let's go ahead and get started on that process. We're trying to solve for all these intersection points, and this is a system. So notice in the second equation, y equals x squared minus 5. So it appears that y has already been isolated for us, so that's wonderful. So that means, we have a y in the other equation. So I'm going to take all this data and I'm going to plug it right here. Notice the squaring would happen on the outside. So what does that look like? That looks like x squared plus open parenthesis x squared minus 5 close parenthesis squared equals 25. Notice there's my other y equivalent. Now, if you see, I have nothing but x's to solve for. It'll take me a few minutes, but that's all I'm solving for in this case, and then I'll find the y's later. So here I have x squared plus, I need to write this twice, y twice because it's got the exponent, and so I'm going to have to multiply a binomial times a binomial, and that'll give me x to the 4th minus 5x squared minus 5x squared plus 25 equals 25. That would give me my leading my leading term would be x to the 4th because we put it in descending order. I have x squared minus 5x squared minus 5x squared, so that would give me minus 9 x squared, and then this 25 would need to come over here, so that'd be minus 25, and notice they cancel out, so then it's just going to equal 0. And so here I need to factor this. They have a GCF of x squared, and so that gives me x squared minus 9 equals 0. You can continue factoring here if you want using your difference of two squares. I'm not sure why the screen keeps getting blurry. Or you could just set each of them equal to 0 and solve. So x squared equals 0 would just be the square root of 0, which is 0. So there's one of my x's. Here I get x squared minus 9 equals 0, which is x squared equals 9. Do your square root property, which is plus or minus the square root of 9, which would be 3. Don't forget your plus or minus. So again, in regards to the answer, I kind of don't want us to lose track of what we're doing. We apparently have a 0 for one of my x values. I have a negative 3 for one of my x values, and I have a positive 3. So my job is to figure out, okay, what are the y values that go with each of those? And so you're going to back sub each one of these x values into one of your equations. And let's be honest, the second one's going to be the easiest. So for case 1, x equals 0, that would be, we're going to do y equals x squared minus 5, y equals 0 squared minus 5, and we get, of course, y equals negative 5. So one of my answers is 0, negative 5. Let's see if that's true. Here is 0, 1, 2, 3, 4, 5, and sure enough, it's right here. Here is case 2, where x equals negative 3. Again, I'm going to choose to do that second equation, y squared minus 5. Y equals negative 3 squared minus 5. Y equals negative 3 squared would give me 9 minus 5, and I get y equals 4. So that one would be negative 3, 4. So let's see if that's true. 1, 2, 3. 1, 2, 3, 4. Sure enough, it's right here. And we do our final one. X equals positive 3. Same equation. Y equals x squared minus 5. Now here's this one, since it's whether it's a negative or positive being squared, I still get 9 minus 5. So I also get 4 for that case as well. Let's see, 1, 2, 3, 1, 2, 3, 4. Sure enough, there's my other intersection. So a consistent system, but now it collides in 3 different places.